Welcome to this masterclass. It's got a bit of an exceptional format because it's longer and it's in two sections, in two parts. But when Jersey asked me to give an introduction to charming to a bunch of people, I thought, well, I mean, we have excellent documentation these days, but it's time to update our recorded content as well and make this available to more people out there, those who could not be here live with us today. So yeah, like it's a bit of a mixture between a masterclass and a workshop, in the sense that I encourage you folks, dear audience, to intervene with questions and try to follow by doing, by repeating the steps that I'm taking on my machine. It's going to be a bit of a hands-on demo. I plan to really show how I do things. There are some notes that you can follow, and that is also the starting point of the masterclass, and it's this GitHub repo, which I just shared in the chat. All right, so the repository is at canonical/intro to charming NC for masterclass, and it consists of a number of branches, unless something broke. Yes. There are three main branches that we should be concerned with. It's part 1, basic setup, part 2, integration, and those we will cover today, if time allows and everything goes well. Part 3, observability, is going to be tomorrow, the next part of this masterclass. The idea is that I'm going to work on local repository. I'm going to show you how I write a charm. I'm going to talk to you through about the basics of charming without, like, yeah. And at some point, I'm going to switch branches. So, and let's say, like, refresh my local environment, so that if some of you couldn't follow, or lagged a bit behind what I was doing, you're not lost in the middle of a broken charm, but can actually catch up at some points throughout this presentation. Let me know if you have trouble finding anything in this repository. One more disclaimer is that I've been asked to give particular attention to machine charms. As you know, there are machine charms and Kubernetes charms, and the main distinction is that the ones run on machine models and the other ones run on Kubernetes models in Juju. However, I mostly work on my day-to-day on Kubernetes charms, so I know some of the tips and tricks of machine charm development, but yeah, I'm probably not the expert on those. So yeah, I hope I don't say anything too wrong, but our documentation, as I said, is excellent, so you're welcome to refer to that whenever you like. With that, let's start. The tools, or let's say instruments, that I plan to go through in these 2 sessions that we have are, first and foremost, Charmcraft, which is the entry point to charm development. Secondly, well, a bit of the Juju CLI itself, even though I'm going to assume that most of you folks know what Juju is and know how to, maybe you already have a Juju controller that you have access to. Is that a better? Yeah, actually, that's a good show of hands for those of you who have no idea how to deploy Juju or don't even know what it is. All right, okay. That is, okay, good that you say that. So I'm going to take the introductory part a bit more slowly. The other tools that I want to mention, anyway, are more focused on the development and debugging aspect, because, yeah, like from what I understand, you folks are interested in writing charms at some point. So I'm going to talk about JHack, which is a tool for, well, let's say, development and debugging of charms. Yeah, it's a collection of scripts, essentially. And I'm also going to talk about ops, the operator framework, which is a Python library that we use to write the charm code, and scenario, which is testing framework for charm code, unit testing, or state transition testing. We'll see. So what is Juju? Juju is a model-driven operator runtime, I would say. I'm sure the official description is different, but that's how I like to think of it. The main raison d'être, the French can translate, of Juju is to abstract away the cloud resources as, you know, compute and storage and networking, and like hide those details away and offer a baseline API for operators to work with. So the promise of Juju is that it doesn't matter what kind of cloud you are deploying your workloads to. It could be EC2, it could be Google, whatever, doesn't matter. Your software is going to run the same. With that, there is one big, let's say, unresolved, or let's say not yet abstracted distinction in the cloud space, which Juju does not address yet. There are thoughts and plans on how to do it in the future, but that is Kubernetes versus non-Kubernetes, versus virtual machines versus Metal, or yeah, let's say we call them machines. So it's machine or K8s. And that means that there are charms that you can deploy on Juju when Juju is running on a machine controller, let's say, on a machine model. And there are charms which you can only deploy on Kubernetes models. Okay, with that in mind, the main entry point to Juju. So when you how do you install Juju? Juju is a snap, right? So if you do snap info Juju, you can see that I have Juju 317 installed, which gives me access to a command line tool. This command line tool, or let's say the Juju that runs on my machine right here, I will always refer to as the Juju client. The Juju client can interface with any number of Juju controllers. Juju controller is something, it's an agent, it's a thing that runs in a cloud, where the cloud could be, again, any of the big public clouds, your private MAS thing, a Kubernetes cluster, your local micro-K8s cluster, right? So a cloud is any of the above. And that is also the biggest abstraction, the biggest box that Juju can reason with. If I write Juju controllers, you will see that at the moment I have access to 2 local LXD controllers, so 2 localhost machine clouds, and 1 localhost micro-K8s cloud. This is the one that I use for my daily development. Your setups might differ. You might have your clouds on on GKE, or on some public cloud, or on bootstack operated things. And so you might have to, proxy your connections elsewhere. They're not going to be on localhost, they're going to be somewhere else. But if you do Juju controllers, that is how you can see what clouds Juju is aware of and has credentials to. That is something that I don't usually work with because I work on local Kubernetes, but it is something you might have to keep in mind. So the controller, the Juju controller, is bootstrapped to a cloud. That is the terminology. So when you want to initialize a new cloud, you can do Juju bootstrap, for example, microK8s, and that will create a local microK8s cloud that you can use for local development. Again, all of these are basics that I was not planning to cover in this tutorial, but you can find the tutorials online. I'm going to try and focus more on the charming aspect, which is what I'm better at. The second building block of the Juju picture of the world is the model. If you're familiar with Kubernetes, models translate pretty directly to namespaces. If you're not a Kubernetes person, I don't think that there is a similar way of distinguishing in machine world, maybe something like regions, but again, like it's a distinction that is not enforced in software. Probably it's a more abstract one. So if I do Juju models, you can see that at the moment I only have one model, the controller model, which is the one that gets created by Juju when I bootstrap Juju to this cloud. So I am now on the LXD cloud, so I'm on a machine cloud, and this is my controller model that gets provisioned for me when I bootstrap this cloud. If I do Juju add model demo, for example, it is going to create for me a model called demo, and now we can see it in Juju models. You can see that it has 0 machines and 0 units, right? So it's an empty model. It's effectively a namespace that contains no workloads at the moment. There's nothing deployed to it. Inside the model live applications, and applications can be scaled to units. Right, so when you want to deploy a workload to Juju, you do that essentially by creating an application. An application is, it represents a workload that then can be scaled out to multiple units. So at first, when you deploy a charm, which is the Juju concept of an operator, it gets deployed as a single application, single unit. You can deploy a charm multiple times, resulting in multiple applications, and then you can scale them up individually and independently. I'm going to show this actually. Let's do localhost. So this is a Juju model, which is a bit more rich. This one has cause light deployed in it, and you can see that there are 5, 6 separate applications deployed on it: Alert Manager, Catalog, Grafana, Local, Prometheus, Traffic. So these are all my applications, and they all have 1 unit each. But I could, for example, Juju add unit low-key bunch and 1, and that is going to prompt low-key into scaling up. So the application now knows that I just requested provisioning a new unit of low-key, and there it is being created. So now I have low-key 0 and low-key 1. So this is a Kubernetes model, but exactly the same applies to machine models. There's no difference in that respect. The second bigger, or let's say, what makes actually Juju unique, if you compare it to other operator frameworks or similar cloud orchestration platforms or model-driven toolkits, is the concept of relations. We're going to talk a bit more detail tomorrow, or no, actually, in the second part today, I was planning about what a relation means in practice, but you can, for now, think of it as shared key value storage between two applications, between two charms, that allows them to exchange information and effectively configure one another in an automated way. The reason why this is so important for Juju is that this allows you to write charms as I would say as a collective, right? So you're not writing an application operator for this single application. You're writing operator logic for how this application will configure itself in like depending on how other applications that are related to it are configured, right? So, for example, in traffic, traffic is an ingress operator. So the goal of traffic is to provide ingress to other charms. So the Prometheus charm, for example, wants to be ingressed by traffic. In before Juju, in the pre-Juju era, that might mean going into the Prometheus machine, obtaining some like host name and IP address, or what's called some port information to know what address Prometheus wants to be exposed to the external world. Then SSHing into the machine running traffic or pod running traffic, and updating the traffic configuration file to forward traffic traffic, not to traffic, but traffic, from a given URL to the Prometheus address, right? But in our case, with Juju, we do that automatically. So what we see is that this is how a data bag or a relation looks like from a data perspective. Prometheus forwards to traffic the host name, the mode, let's say, the scheme essentially that it wants to be exposed at. It exposes the port and traffic, if traffic were configured. Traffic replies with a URL, if it works. There we go. So essentially, this is Prometheus writing to this shared key value pair database, which we call a data bag. Prometheus sends some information to traffic, and the meaning of this relation is, please give me back a URL, my ingress URL. And traffic replies with, there's your ingress URL, and also configures itself to actually forward traffic, HTTP traffic to that URL. So this is the kind of automation that writing charms enables you to do, and that is why charms are so interesting and why Juju is powerful and just cool. All right, let's take a look at what a charm is from a code-first perspective. So I'm going to start from an empty repo. Nothing special or fancy about my setup. I use PyCharm. I have, well, nothing really. A Python 3.10 environment, virtual environment, and no special packages of nodes. I have Charmcraft installed. I have jhack 031912. I don't really do semantic versioning. And microcates, yeah, these are some versions you can look at. And then snapping to Charmcraft, I'm at 253. So what happens when you want to write a charm and you type Charmcraft init? Charmcraft init is the, let's say, the entry, or like the first command you run when you want to bootstrap a charm repository. A lot of teams have their own templates, GitHub templates, or you can copy paste an existing charm and so on, right? But this is the low barrier entry point for everyone who wants to start charm. So Charmcraft init will create for you a bunch of files, a directory structure, and that you can use to then fill in these files with information and code you need, and to obtain a charm. There are a couple of different templates that are available to you. There is the Kubernetes template, there's the simple template, and there's the machine template. In this case, again, we're going to work on a machine charm, so I am initializing this charm repository to use the machine profile. And yes, thanks, Andrea, for mentioning again that there's this dev setup for the multipass blueprint. You can use that to obtain automatically all of the snaps you need, all of the jhack, all of the tools you need to do charm development. The files created by Charmcraft are the ones in red here. You can see, well, I mean, in some respects, it's just a standard repository template. There's a license file. It's a standard Python project template. There's a pyproject.toml. Requirements txt containing only ops, which is, I will mention that a bit, we'll go a bit more in depth there, but it is the Python library that you may interface with when you're writing charms. And there's a tox environment. Tox is essentially, well, you can think of it like Makefile cooler brother or sister. It allows you to define a number of environment, and if you run tox -e and then name of the environment, for example, format, or I usually call it FMT because I'm lazy, it will run the commands defined in the environment. For example, rough formatter, or linters, or unit tests, right? So you can do tox-e unit, and it will run your unit test suite. And this is handy, especially in combination with setting up your CI. In the observability team, we have a CI which assumes the presence of a bunch of given tox environments, for example, static, integration, unit, and it will run them on every pull request, for example. That is just useful for automation to let it be known how you want your charm code to be tested, or how you want your charm code to be linted, and so on. From a very, very abstract point of view, what is a charm? Charm is a Python script. Charm is a Python file. The most minimal charm you can possibly write in Python, because there have been previous iterations of this framework and they were not based in Python, but how you write the minimal charm today using ops is to have a file containing a charm class and a call to ops main, or just ops.main. It's a module, but it's callable. They made some trickery to make the module callable. funny Python if you want to go and look at it. What happens when when you execute this file? Well, that is where the Juju story gets interesting. Right. Let's take a bit of a step back. If I do charmcraft pack, I'm not sure now it's going to work. It should, because it's a bare repository. But what it should do is it should produce a zip file, essentially, called intro to charming MC, and then some suffix for the base that I'm using. So Ubuntu 2204, MD64, and then the extension .charm. If I open that in my file, my Explorer, intro to charm MC. If I open it up in my WinZip, this is what I'm going to see in there. It's pretty similar to the repository that we see, but there are some differences. So you can see that there is an SRC. There's my charm.py in there. You can see that there are my tests. You can see that there is license, docs, PyProject, charmcraft, metadata, manifest. Okay, so these two are new, metadata and manifest. This one is new, dispatch. This one, I honestly don't know what it does. Metadata.yaml, that is a good question. Well, so charmcraft very recently changed their metadata model. So this is the first version that I use, where when you run charmcraft init, it creates a charmcraft.yaml, but not a metadata.yaml. The previous template used to give you something more, well, I don't really have a simple charm repo here, but this is the traffic repository, for example, and you see that there's actions.yaml, config.yaml, and metadata.yaml. Nowadays, they've all been squished into one single file called charmcraft.yaml. So if you look at an old charm code base, you will see these three different files. But if you look at a charm that's being created more recently, you will find that there is only one YAML, charmcraft. And yes, less YAML is better YAML. So since we want to, since we want to do things the future way, this is how you write a charm. Now, charmcraft.yaml has, as far as I know, only these required arguments. It requires bases, description, summary, and type and name. So these are the only fields that are really necessary. Charm name, well, that's self-explanatory. There is a comprehensive style guide that I'm going to link in the chat. The Juju IS docs SDK style guide, which contains a long list of conventions, best practices, and so on, starting from charm naming. There's even a separate document on the do's and don'ts of charm naming. So when you create your first charm, if it's at least meant to be a production charm, take a look at the style guide, because there are a lot of things that you need to consider. But this one is a demo charm, so we don't really care. We can call it intro to charming MC. Type charm, that we cannot change. It's just a way to tell charmcraft that the object whose metadata you're describing is a charm. The title, we can modify this as well. Demo charm for intro to charming MC. And similar, you can edit the summary and the description. The bases, yeah, I honestly never touched them. You might want to, if your charm is meant to run different Ubuntu versions, or pack on different Ubuntu versions. Oh yeah, we were looking at the difference between the packed charm and the unpacked charm. So I think it's useful if you try to understand what a charm is and how it works in the context of Juju, to really take it low level, right? To start low level. And if you want to start low level, there is nothing as low level in charming world as the dispatch script. The dispatch script gets injected in your charm by Charmcraft, right? So you write Charmcraft back, and Charmcraft creates this dispatch file and plugs it in your charm, unless you have defined your own, but that is a pretty exotic use case. I've never seen any charm doing that, but in principle you can, just so you know. And what it contains is, in fact, pretty simple. It just edits a little bit the Python path so that this lib folder that at the moment we don't have, but we'll see that later, and the vend folder, so that they are importable from dot, and then it executes charm.py. Charm.py in turn is executable, as in it has a shebang that you can use to, command line dash will recognize. And so when the dispatch script is executed, all it's doing is launching charm.py, plugging in a little bit of Python path that, just for convention, we assume charms will want to work with. Let's take a look at deployed charm. I always do this wrong. Okay, there we go. Do I have tree? I don't have tree. Anyway, there we go. So you'll recognize some of these file names. Again, this is traffic, so old style charm. So we also have actions and config. And, but in a nutshell, when I do Juju deploy name of the charm or path to a local charm file, that file gets uploaded to the Juju unit that has just been provisioned for me. It gets unpacked in here, and dispatch, as you see, is right there and is executable. So the way that is in fact the main entry point to the charm. When the charm executes, what it actually means is that dispatch is being executed, which calls charm.py and executes Python in turn. That is just very high level or low level, but it's also very useful to know and understand. You'll notice that I like diagrams, and so here's another one. Yes, I will repeat the last thing in a second. What happens in a nutshell, and this, by the way, you can find on a document that I link here. What happens in a nutshell when I type a Juju command on a CLI, such as Juju add relation, Juju remove relation, or anything that affects the charm, or Juju deploy. The Juju CLI, which is the Juju client, on my local machine sends a gRPC, if you need to know, call to the Juju controller. The Juju controller changes something in its internal state and then notifies all of the units that contain charms of the change that has just happened in the Juju model. This we call an event. You're going to hear a lot about events in these two sessions. Charms are effectively event-based control logic for cloud workload operations. That is the broadest definition I can think of. And what does it mean for a unit to receive an event is what I was just talking about a minute ago, that the unit executes dispatch, which in turn calls charm.py, which executes the charm logic. All right. Let's take one look again at the charm.py source. We have this code block. If I guess, I don't know if I can assume anything anymore at this point, but assuming you know a little bit of Python, what this does is make this file, let's say, executable in a way that, all right, so like this is just a class definition, so by itself it does nothing except define a code block, but it does not execute the code block. This, in fact, is the thing that is executed when you run this file. So this is a call to ops main, and we pass as an argument this charm. So in a nutshell, when you when a Juju unit receives an event, this file gets executed, which means that we call ops main passing this charm class as an argument. Okay, so Juju works with agents. There are, in the picture that I've sketched so far, there are at least two agents involved. One is sitting on the Juju controller and is the one that maintains a picture of the model, a picture of the world. So when I did Juju add model demo, this sends a piece of data to the Juju controller, telling it, please update your internal state so that now there is a model called demo. When I do Juju, wait, let's switch models. Let's do, when I do, and the admin demo is empty, so this is the model that I've created before. When I do Juju deploy and then intro to charming and C intro, this is uploading the charm file, so that zip file, to the controller, and is also telling the controller, please update your model so that this file, so like the charm that I am sending you is deployed with scale 1 in this model. So this is another model update. When I'm like, every time that that a unit of a charm of an application is provisioned, there is another agent that comes in the picture, and that is the unit agent. So we have one Juju agent living in the controller that is kind of like the responsible for the state of the model, and then we have another agent sitting in each, so like n agents for n units that we have in our model. So in the model, in the other model, and case cloud localhost that I have, In this other model, there are going to be one unit agent for each one of these deployed units. And what happens? What happened before when I do Juju? For example, let's now do a remove unit low key. Not units one. It's now what had happened now is I sent a signal or a message to the controller, to the Juju controller sitting in the model, in the controller model, in this controller. And that updated its internal state to say, well, there are no more 2 units of low-key. There's now only 1. The next step, so like the controller updates this internal model, and then there is this piece of very complicated Go code that continuously attempts to reconcile the current state and the desired state, if you like, where the desired state is the one that the user is dynamically specifying in time. So, for example, the model at the moment has 2 units of low-key. So the model, the model says there are 2 units of low-key. But I just told Juju, well, get rid of one of them. So Juju, the controller agent in particular, is aware of this difference, of this discrepancy. Hey, I have 2 units in the model, but I'm supposed to only have 1. Well, let's destroy one of them. Okay, so this is the reconciliation logic. But, and that is crucial for the operator logic that that we have to program in our charms. The controller is not just going to nuke a machine under your feet. It's going to send notifications, events, that is what we call events, to the charms to notify them of changes happening in the state. What does this look like? So this is another tool in JHack. It's called Tail, JHack Tail. JHack, by the way, is also a snap. I didn't introduce it properly. JHack 03.5. I'm using it from sources. Hence, you see me typing LJHack. It's for local JHack, but you can install it from Snap, and it's going to be the same. What does tail do? So tail is a command that listens in the background for events occurring in these units and displays them in a table, in a pretty format. But if you want to go at the lowest level, you type Juju debug log, and that gives you a stream of logs from the current model. And some of these logs are going to tell you the charm has received an event. Let's see if I can find. Let's grab ready. There we go. Running book, table ready. All of these logs are, some of these logs are informing you this charm has just executed with this event. And this kind of, at least in my head, tell me if it's not, if it was not clear. But in my head, this kind of closes the loop, right? So there is the Juju controller that keeps track of what changes are happening in the model, or at least what the user wants to happen in the model, fires events to the charms that these changes are relevant for. For example, it fires an event to Loki/1, so the other Loki unit. You're about to be torn down. Do something about it. And that gives, so that executes dispatch, that executes charm.py, and that executes the logic that we write in Python to manage whatever needs to be managed if something changes in the model. So yes, Bill, exactly. There are some basic hooks, and there are also relation hooks, and there are also storage hooks. There are action hooks. There's a lot of hooks. Yeah, there's also a link on how to use jhacktail, as I just showed, but this tells you what the event life cycle looks like from the perspective of the charm, right? So I like to think of the big picture of the events coming from Juju, from this model reconcile, but like a charm knows nothing of that. A charm, as in, you know, the Python script charm.py, only knows I'm being executed with these environment variables, and I have these hook tools, which are bash scripts, shell scripts that I can use to ask some more pieces of information to Juju, from Juju. But that is all that the charm knows about the world, and we'll get back to that later when I talk about the state transition model of charms. You can say that a charm has three phases: the setup phase, the operation phase, and the tear down phase. The setup phase is the transition, the events, the sequence of events that a charm goes through when I first deploy it. So when I switch LXD, this is all of the events that this charm has ever seen since I've deployed it, right? So this is the start sequence. When I deploy a charm, these are the things, these are the events that Juju will fire on it. Okay, so before I go on, note and like always be aware that that Juju can be kind of unpredictable when it comes to the ordering of events. There's always new charmers confused about it and asking questions, and there is some determinism to what events will follow other events logically, but Juju is like makes very little promises when it comes to event sequences in a charm's life. These arrows that you see in this graph, these are, to my knowledge, to the best of my knowledge, the only guaranteed, at least time-wise, event sequences that you can expect when you write a charm. And again, they are so little that in practice, when you write a charm, you mostly try to make as little assumptions as possible as to when you will receive a given event relative to another event. That is part of the complexity of writing charms, and that is why we often, at least in simpler charms, opt for what we call a holistic charming approach, where instead of looking at or exclusively at the event that you are receiving and processing right now, you straight away ignore it, or anyway, you take into account the state that it is. So the state that you are in. So what relations do you have, whether your workload is running, and so on. You're asking if there's a live illustration with an event flow, for example, when a new peer joins, or any other common Juju scenarios. That is a good question. SDK And then I would go into reference events. And here you can find, by the way, another more just prosaic list of Juju events. And if I remember correctly, each one of these event pages, for example, this is the reference doc for the install event. It contains an emission sequence section, and the emission sequence details in what situations this event will be emitted on a charm. And there's also a table of scenarios. For example, I create a unit, for example, when I do Juju deploy foo, and then the resulting event sequences that you should see in the tail or in the debug log. So you can do this this is we try to uniform this in each one of the event pages. So you can just go into any of them and you will find in the mission sequence Juju command and then what events you can expect. But again, big disclaimer about the timing of these events. There is some guarantees about the setup phase, but much less about the other phases. If a charm is in the operation phase, is it possible to get events that belong to the start phase? Yes, some of them. You are, as a charm, like, it's a bit of a, as I said, it's a bit of a fuzzy distinction, but it depends on the semantics of the event. For example, leader settings changed and leader elected. You receive whether, like, when you respectively lose or gain leadership. I've not talked yet about leadership, but quite simple concept. But anyway, and that is why also they are here in the operation phase, by the way. So I tried to repeat them in the graph whenever it makes sense. But for example, you will definitely not receive an upgrade charm during the setup phase, and you will not receive an install or a start during operation or teardown. If you do, it's a Juju bug. There are I recommend that you go through this document because there are lots of subtleties about this event model. More than I can go through in today or tomorrow. But Adam, please.
I think that can be slightly confusing because in this diagram you've got config changed in both in the start and in the operation. Yeah. And config changed is something that can pretty much happen whenever, right?
Yes.
So it can be misleading to identify one of these blocks and then say, okay, it's only, like, if I were to go and pick update status and say, okay, update status is in operation phase, config changed is in more than one of those phases. So it's that is one of the risks of putting it into a diagram, that it might give the wrong impression. But what I mean to say by putting config changed in start, especially in this flow, is that you are guaranteed to get a config changed event from Juju during the setup phase. So there it is, right? So you see leader elected, config changed, start. So this is this path: leader elected, config changed, start. And what I mean to say by putting it in this graph in the setup phase is that this section is pretty much fixed, right? So let me see if I can minus 10 or minus L10. But anyway, the charm will go through these events, and then after it receives the start event, then it's kind of Wild West. The operation phase is the fuzziest one, where pretty much anything can happen. Indeed, more update status, more config changed, and all sorts of other events. We should have, at this point, have comprehensive-ish picture of
from Juju CLI to events. And an event, again, reiterating on that, an event is processed by a unit, which means the dispatch function is called, charm.py is executed with a given environment. If, and the charm, so the operator framework, which is that piece of it's a Python library called ops, and that Python library does all that it does, simplifying a bit, is wrapping those environment variables in a way that you can read them in a Pythonic, easy to understand API, and wrap the hook tools, which are the only communication channel between the charm and the Juju controller. I might need to say something a bit more about that. The Juju controller, as I already mentioned, it hosts this model. And this database, so this model database, it contains a number of things that are meta. So, for example, how many units there are, how many applications there are, what they're called, and so on. But it also contains information that is of interest to the charms themselves, so to the operation logic of this whole machine. And that is, for example, relation data, so the content of those inter-charm communication channels, and charm config, which is, again, a key value store used to configure a charm at runtime. And, well, the event, or at least this is how I like to think of it, the event is a little data structure, quite minimal, in fact, that gets presented to the charm as environment variables and tells the charm, this is why you're being executed. It tells the charm, for example, you are being executed because you are being started, because you are being torn down, because this relation has been added, has been given access to you. This secret has been granted to you. And that is only the event, right? So the event tells the charm the why. Why are you being awakened, if you like? The charm can also access other pieces of information that are not passed to it via the event. And that I like to call the charm state. But yeah, there are different terminologies. We haven't yet settled on one, I think. But that is, for example, relation data, config, stored states, and all that stuff. So if I go back to the traffic charm container, this time the right one. Oh wait, no, the wrong model. Let's see if this works. That's interesting. Again. If I go into the charm and look into this directory called tools, you'll see there a lot of shell scripts, shell scripts that I think behind the scenes result into more gRPC calls to the controller, but to be honest, I've never looked in there. hook tools. There we go. I wanted to find this piece of documentation for you. Now, these scripts are called hook tools, and you can find them in this documentation page, categorized by the type of data that they provide access to. Some of them, well, most of them, I guess, are about retrieving data from the Juju model. For example, status get allows a charm to say, to ask of Juju, what is my status according to your model database. Status set does the opposite, informs the model, this is my status now. And by the way, the status is what you see here, active, idle. So what's important to understand here is that these hook tools are the main communication channel between the charm as as live runtime on a unit and the Juju model. The ops framework offers, on top of well, it wraps the event, as in the environment variables that are used to execute this charm, and it wraps the hook tools. These are the two main responsibilities and jobs of the operating framework. So when you write charm code, there are mainly two tasks that a charm should accomplish. And the first one is to observe the right events. If you're familiar with the observer pattern, this is what the operator framework and charm codes implement. For example, what this line of code says is whenever I charm am receiving a start event, execute this callback, this method. Ops, this framework, will ensure that this method is called receiving an event object, which is, in this case, pretty uninteresting. The start event does not contain much extra information. It's like there's not much use to it. We could also just ignore the arguments and be happy. The second task of a charm is that to do something with that event. For example, what we're doing in this case is we are setting our status to active. So going back to the LXD demo model, you will see that the charm that I have deployed after packing this code says active, idle. So idle means that the charm code is not executing at the moment, and so far as we know, everything is fine. Active means, so active is the workload status that is set by the charm. So if we see an active here, it means that the charm has told us everything is fine, and like this is my status. There are different statuses, and they have different semantics. There is active, which is basically everything is fine. There's blocked, which means there's something wrong with my configuration or my setup, and some administrator intervention is needed. Please come fix me. There is waiting, which is similar to blocked in some respects, but it might, like in some people use it to mean that you just need to wait some, because, for example, we're waiting for a relation to occur, or we're waiting for some events, to happen. There is maintenance, which is the status we set typically when we want to do some long-running operations on the chart itself. So, for example, you could do my status is maintenance, and then do something that takes 5 seconds, and then set my status to active, right? Status is pretty much the
only piece of information that is communicated to Juju live, as in synchronously. All the other changes that a charm does to the Juju model are only communicated to Juju if the charm exits 0. So what this means is that if I were to set some relation data or create a secret or something like that, and then raise an exception, uncaught, just error out, that change would never be committed to Juju. That is handy to know. Now, let's play a bit around with this very simple charm. What I like to do is this. Agents charm. Okay, so here we have, oh, we're in traffic, right? Just SH, and then let's go to intro 0. Okay, now we are in a machine, by the way, so you also see that the prompt is different. We are in Ubuntu, in fact. Agents, unit intro 0, and charm and C. Okay, there's our charm.py. There's our charm. Do we have Vim? We do. All right. That's nice. So what happens if we do X? So this is, like sometimes it's handy when you're developing a charm to, instead of, so like the typical way you do, or the slow way to do charm development is you write some Python code, charmcraft pack, which you'll find out can take very long, Juju deploy or Juju refresh to publish or deploy the charm code to your Juju controller or model, and then wait for the events, wait for stuff to happen, and so on. But there is also the fun way, which is to, what is happening there? Why cannot I edit it? And to open file for writing. Okay, I'm confused. This is the demo effect. Okay, so how I'm going to do this? Let's do it this way. Let's do it with the shortcut. So jhack contains a command called sync, which basically does what I was doing manually, but from sources on localhost. So if I make this change, commit it, this pushed my file up there. So now we have the code right there. So I'm not sure why the file is being weird about being changed, but we obtained what we wanted. Now we have made this simple change to the charm, and now we want to test it. How do we test it? We can execute the unit. We can execute dispatch in particular. So this will, yeah, we need to pass the full path. Charm/dispatch.
So what this command is doing is essentially simulating an event, right? So it's executing the charm, it's executing dispatch as if the charm had received an event from Juju. Why don't we see any changes to the status of this charm? We don't see any changes because this event handler was on the start event. And this dispatch, so we are calling the charm. We are not, in fact, emitting any event on the charm. We're just executing the charm, but the charm does not know that there is an event happening. To overcome that limitation, you can do a lot of hackery to manipulate the environment variables and convince the charm to execute as if there was an event happening. But JHack also does that for you. So what I did here is I manually emitted this a start event onto this charm, which, if you remember, where's the translation? Which, if you remember, is part of the setup phase, right? So this event, which normally now we are in the operation phase because the charm is deployed and happy. We shouldn't really see that event here, but yeah, we're hacking around, so we can simulate a new one. So now the charm is convinced it has seen a start event, so it has executed this onStart event handler, and it has set its own status to active. And hello, Masterclass. Let's change that to maintenance. Save, commit, and repeat. There we go. Now it's in maintenance. Hello, Masterclass. So I really like this flow because it enables you to make changes fast to your charm code, test them in real life, and run events over and over. What should we do with this very basic charm code? My plan was to, well, my plan is, and we still have some time, so let's do it, to write a charm that can deploy to some form. It doesn't need to be a fully, production-ready charm, of course, but we want to deploy Nginx. Let's say that our charm wants to deploy Nginx. What do we need to do in order to deploy Nginx? Well, Nginx luckily comes with Ubuntu installs. So all that we have to do is enable it and configure some firewall rules so that the traffic will not be blocked by the firewall. So we go back to look at this graph, and the event that typically we listen to when we want to install software on the machine that we're deploying our charm to is the install hook, as you can expect. So let's observe install. We listen to the install event, and active is fine. But, well, before we can say Nginx is ready, we actually need to install Nginx. So let's install Nginx. And in order to do that, we do this. Let's create a simple script. Update, install Nginx. There we go. So this is the installation script for Nginx. And secondly, we are as I mentioned, dropping in some configuration for UFW to allow Nginx HTTP traffic. And, well, this is basically all we need, I think. Now, just to let's repack this thing. My there's my favorite JHack command is nuke, which allows you to destroy stuff in the most impolite possible way ever. So please do not use it in production. But it's just gets rid of models, units, machines, whatever is in your way. So we can now deploy again. And let's deploy it to Nginx demo. It's the same charm, I'm just giving it a different name. Now, let's Juju SSH. As soon as the machine is provisioned, we're going to SSH in that and see if Nginx is running. I'm going to tail to see when the charm receives the install event so that we can, oh, I forgot, I didn't forget. I wanted to do this. But yeah, it's taking a little bit of time. But what I expect to happen is that the charm processes the install event, which triggers this method. I execute the script, apt update, or oh yes, that was the catch. I actually need to do this, because otherwise it will kind of fail if I do this in script. Install Nginx Y. Yes. But yeah, we're going to, there we go. Yeah, it's a bit too late for us because we have already seen install, redirected, config change it, and start. So the charm has already gone through the bootstrap phase. So if we go to systemctl Nginx, we're not going to see anything. So again, the slow development cycle is, or the regular vanilla development cycle is, you make changes to the charm code, you do charm code pack, and then you redeploy. But again, I'm lazy, so the way I do it is call sync, make touch the file that starts it up, and then I make I use JHack to hack my way around it. So now you see that the charm is going through the statuses that I configured. So now it's in the installing Nginx. Not sure what. Oh, this is the login message from the charm execution. And now we are at Nginx ready. Yes. And now, if I do systemctl grep Nginx, loaded, active, running. Right. So this very simple, super simple charm, it installs Nginx. Now, the next phase, the next thing that I wanted to show to you today, and I think we still have enough time for that, is well, how to add
an integration to this charm, which is, again, that's basic, but also fundamental step to charming. Why jhacktail didn't recognize the fire event? That is a very good question. And the answer is that when you execute the charm by using Juju exec, which is what jhackfire is doing in the background, ops knows that, I think it's ops fault, yeah, or is it, well, okay, let's be honest, I forgot where it goes wrong, but there is something that gets logged in a slightly different way, or maybe just with a different log level. I forgot where it goes, but anyway, it does not appear in the Juju debug log like all other regular real Juju events do. So if I do Juju logging on, which is my alias for Juju model config, logging config, bootworn unit trace, then I do our Nginx demo, and then let's do update status, something like that. Ooh. Yes. Then, all right, okay, there we go. Was probably stuck on something else. Yeah, there we go. Then jhacktail will pick it up, and it even will realize that it's a different event, like that it's not a standard event, right? And the way I do this is, so this is the log emitted by Juju. So this tells, this is the one that we pick up regularly in jhacktail, and that is the one that allows us to print start. And then I emit this log line. The previous update status was fired by jhack, which then jhacktail uses to add this little fire icon to tell you this start event was not a real Juju event. It was fired by jhackfire. But if I do now, I don't know, something like Juju add unit Nginx demo 1, then you will see a bunch of new events come up in tail for the Nginx demo 1 unit. And as soon as that comes up, I'm going to fire a start in there just to show you the difference. Any more questions before I go into relations? All right. All right. Relations. Relations are, well, yeah, I'm gonna pick it up later when we get to it. Relations are, or okay, I should call them integrations. That is the modern lingo. Integrations are the way to integrate charms with one another and make them exchange information. How do you write an integration? So the usual way that people go about creating integrations is with charm libs. Charm libs are single Python files that behave in like they are Python modules, and they can be exchanged pretty much like a PyPy package can, but with less bells and whistles and less, let's say, less ease in a way, but also just less clutter. What do I mean by can be exchanged? Yes, if I do charmcraft create lib demo ingress 1, and I do 1 because I've already created demo ingress. I'm authenticated. Okay. So before you can do this, you need to register your charm with Charmcraft, which is very simple, based on this name. So it needs to be unique. So I've already registered intro to charming MC. So if you try to do this and it fails, you need to create a unique name for your charm. So first you do Charmcraft register that name, and that will create an entry in the Charmcraft database and associate it with your identity, so that no one else can do stuff on your behalf to this charm. Then if I type Charmcraft create lib demo ingress 1, that created a Python file in this place, and that is over there. This file, at the time of creation, contains a big doc string, which we ignore. It contains a lib ID that you're never to touch. It's a unique identifier that Charmcraft uses to identify this file. And then this is the major version, lib API, which also matches to the v0 directory that this file is nested in. So also do not change this unless you change that. And this is the lib patch. So I'm not going to go too deep into the whys and whats of charm libs, but this is a charm lib. And if I publish this lib as charms intro to charming MC v0 demo ingress 1, it has been sent to the store with version 0.1. And if you folks write this command in your charm repo, you will get that library. So that is all I mean by can be exchanged, right? So it's a very lightweight way of exchanging semi-versioned charm libraries between charm code bases. And the way, like the reason why I introduced this this concept when I'm talking about relations is that relation code is typically implemented in a shared code base because, well, it's a data exchange protocol, so both parts need to be talking the same language for it to work. And the way that people usually do that is by making the implementation live in a single place, which is a single Python file, which is this charm lib, in fact. Every time you make changes to the library, you need to increment the lib patch. And most charm libs that implement charm relations use what we call a provider requirer pattern. In Juju, if you go to any if you watch at if you look at the output of Juju status, you're going to see that there is a provider and a requirer. If you're familiar with snaps, this is slots and plugs. Say one-to-one. There is very little difference. Why they give it a different name, I don't know, but I hope that helps at least some of you. The idea is that every charm can declare as part of its metadata, these are the endpoints that I can be talked at through. And you do so either as a provider of service, a piece of information, or as a requirer of it. For example, if I'm a database charm, I provide tables. If I'm an ingress charm, I provide ingress URL, ingress routing. If I'm Prometheus, I provide a metrics endpoint that you can use to send me data to. If I'm traffic and I want to consume the data that Prometheus is giving me, then I am a requirer of that endpoint. So what we do typically in charm libs is we create a ingress provider. And an ingress requirer class. And the provider charm, which is typically the one that owns the charm lib, right? So it's typically this charm. Does this. Then this charm lib gets shared. So like I'm going to publish it as soon as I'm done implementing my ingress. I'm going to share this library. I'm going to publish it. And whatever charm wishes to use this interface to talk to me is going to import the ingress requirer and use it in exactly the same way. Now, we haven't implemented any logic yet, right? So this ingress provider class does exactly nothing. But let's try and see if we can get there in a couple of minutes. Let's do that by using a bit of type hints to make us faster. The first thing we need to do, in fact, is, what is it? We need to add a relation to the metadata, because without it, Juju is not aware that the charm can be interfaced with any other charm. The syntax for doing that, yeah, you can see in this documentation how to write charmcraft.yaml, but I'm going to do it by heart. Today's, no, I'm sure that makes a mistake. This is the minimal amount of information you need to add to charmcraft.yaml or metadata.yaml in older charms in order to add this integration, this endpoint to your charm. So if I do charmcraft pack now and I deploy this charm, Juju is going to know that this charm has this slot or this provider endpoint, which, however, still doesn't do nothing because we have not implemented it. As I mentioned, the ops provides a wrapper around the hook tools. So these scripts that we have seen there that are used to communicate with Juju about all things, among which relation data. So typically, and now I'm going to, like, this is ugly code. Like it's we have better practices in our production charm. I'm just trying to make you understand a bit how to reason about this. We obtain the So we talk to the Juju model by using the charm.model interface. If I do charm model relations, this is going to return a list of the relations that I currently have active as a charm. So if I do give me all the relations that I have over the ingress demo endpoint, this is going to return to give me a list of endpoints, or a list of relation objects. So this is of type list of relation. If I have any relations, or actually let's simplify our life and let's assume we only have one. Let's assume we can only give ingress to, well, no, why should we do that? If we have any relations, so we're going to iterate over the relations, and for each one of them call this give ingress. Now let's first ask ourselves, what do we need from the ingress require charm in order to give this charm ingress? So the require, first of all, only can obtain, like, can only have one relation at a time, because, well, it doesn't make sense to have ingress for more than one ingress provider. Okay, probably this might raise if we have no relation. So that's not. So if we do have a relation, and that is again, so like something you will learn pretty fast when writing charms is code very defensively. Like you're never sure that there is a relation, or that the relation has data, or that the relation at the other end has published their side of the data. So always code very defensively. That is you learn that. So if we have a relation, this is the ops way to interface to data bags. So this is essentially equivalent to calling the hook tool relation set host cluster local, or whatever IP address you have in mind. So I'm updating the application data bag with let's put leadership around it. I'm updating the application data bag to contain an IP or port, say IP 80. Yeah, data bags are string-to-string mapping. So if you want to do serialization and deserialization, you need to do it on both ends. So let's think about the logic here for a second. A charm implementing the ingress require. When we are leader, when we have leadership, we always try to request ingress by default, which means if we have a relation over ingress demo, so this interface that we are developing, we take the application data bag of this relation and we put into it host and port. So we publish these two pieces of these two strings. This will communicate back to Juju. It will update a piece of the model, and the charm on the other end of the relation, which is our intro to charming MC charm, will be able to access that data in a very similar way. We receive the ingress, so we receive this. We can access this relation object. This is how we reference the application data bag of the other end. So how relation works, I didn't get too deep into the data bag model, but yeah, actually I mentioned it before with the show relation. Yeah, so that there are always these two sides, the provider and the requirer, and there is an application data bag that in this case is empty. In other cases also empty. That's unfortunate. And then there are data bags that are reserved for each one of the units. So in this case, I'm referring to the remote application data bag. If I did relation units something, I would be referring to a unit data bag. In this case, I put the data in the application data bag, and I know it because I'm doing it right here. And what I'm doing here is essentially a relation get host and relation get port, and ops is providing these handy wrap. And so this is our side, right? This is the intro to charming MC charm that is executing. We obtain host and port, and then we completely arbitrarily we decide the URL is foo.com/u and whatever, and we put that into our local application data bag. So this is our reply. And well, like if we were really working with Nginx, and if we're really configuring Nginx to use this route, at this point, you would use this host and port information to write a config file, or however you configure Nginx, to route the traffic from like asking for this URL to that host and port. But we're not going to do that because it's a demo. So now that we have this logic, there is, I'm afraid, too little time to actually, yeah, let's do this. Okay, nice. Now let's go up, and now we are in the second phase of this charm project, where if everything goes well, I have a tester. Okay, charm pack, and then we go to tester and the charm pack. You missed where the mapping. Yeah, I know we're short on time. We just missed where the mapping between Python class and config provides is set. Yeah, so well, that is done implicitly for you. You missed the mapping because there is no explicit mapping. It's so charmcraft.yaml is consumed by Juju to set up the environment. So like to set up the Juju model. So Juju knows that this charm has an endpoint called in this way, but the provider of this
the provider of the relation is in this object that lives exclusively in the charm code. So Juju knows nothing about it. I'm not sure if that answered the question.
I'm gonna speak just so it's faster. What I mean is, since the part of the action is performed in the initializer for the pattern class, and I don't see any matching names or something that could help Juju imply where to get the code. That's why I was asking, like the demo, like the interfacing they provide, you specified doesn't match the name of the class or anything like that, if I'm not mistaken. That's why I was asking, how do you know which initializer to use for the provided info, and which one to use for the required info?
Well, so Juju doesn't know, in fact, Juju doesn't know anything about it. It doesn't know where to get the code, because all that is, like, let me bring that back. So when this file executes, ops, as in the operator framework, is going to initialize the charm. So it's going to run this init, and this init is calling in turn this init, right? So there is nothing that Juju knows. Juju is not aware of this mechanism.
Okay, so the providing and requiring is part of the basic charm behavior, basically. It's something you add. It's not something that you need to configure. It's just part of the implementation that you write.
Yes and no. So, like, this part is, let's say, Juju specific, and this charmcraft.yaml section is what makes it possible for the charm to relate to another charm.
Yeah.
But once that happens, Juju does not know what charm logic executes to deal with it. So without this section, I could not type Juju relate charm A, charm B.
No, I get that. Nice.
But once I do that, then the charm code kicks in, and yeah, and we do whatever we do.
Nice. Thank you.
Welcome. And well, we're gonna pick this up tomorrow and go on from where we left. Until then, you can take a look at part 1, which is, most of what I covered up until half an hour ago. And then part 2, integration branch, that contains the code for the, let's say, charm that is ready to integrate over the demo ingress relation. And see you all tomorrow. I'm going to stop the recording